So this is still paper 11, October, November 2020. This is your code. I am doing question 7. The other questions 1 to 6 are on a different video. Let us just start with 7a. Trig. Show that. So it's an identity. I normally suggest with identity, you separate them from birth so that you're not tempted to bring things over. Let's just copy down the left-hand side for now. So we've got sine theta over 1 minus sine theta over 1 plus sine theta. That's your left-hand side. The right-hand side, I'm just going to quickly copy it there. But I'm not going to put in equals. I normally divide my whole page, so I'm not tempted to bring anything over. You will notice that your left-hand side actually has 2 terms, and your right-hand side only has 1 term. So my first suggestion when this happens, just check this again. 2 terms, 1 term. How do we get 2 terms to become 1 term? LCD. So you need to find a lowest common denominator. Easiest thing to do here is just combine your 2 denominators into an LCD. So 1 minus sine theta, 1 plus sine theta. Nice. Just remember how this works. If you do an LCD, you have to say term 1, what do you need from the LCD? You had a 1 minus sign, so you need a 1 plus sign. Whatever you had still just needs to chill there. So this is what you need from the LCD. Don't forget the minus sine theta. What do you need from the LCD? 1 minus sine theta. Okay, and now successfully you've made 2 terms 1 term. Just be careful now, don't make sign errors. Distribution needs to happen here. So we distribute and we distribute. Don't make, especially here, don't make sign errors. And then denominator, very interesting, it's difference of squares. If you didn't see it, fine, but it's difference of squares. So you can just FOIL it, or 1 minus sine squared theta. Some things will cancel out. I'm pretty sure that there will be things canceling out here, that and that. So then add your like terms. This will become 2 sine squared theta over, if you remember your identities correctly, 1 minus sine squared becomes cos squared. Excellent, because then sine squared plus cos squared, another identity that's on your formula sheet, by the way, sine over cos becomes tan. So then this becomes 2 tan squared theta. Confirm, left-hand side, right-hand side. Sorted. I love trig. This was very easy. Also just want to see how many marks we got for that. Yes, we got 3 marks. Okay, that was easy, 7a. Hence, next one. Hence, I want to remind you, you have to check for similarities, but you also have to check for differences. So hence means we have to use what we just proved. So this whole part can be replaced with 2 tan squared. 2 tan squared theta. So you need to know how to hence. Yeah, hence can be a verb. So we replace that whole thing with tan squared theta. Just writing down everything so I can stop sharing. Okay, so just check what I've got for you so far. Obviously I was drinking coffee. You can see there, that's the most important part, is drinking coffee while you do maths. Making perfect circles. I've got this from hence, and then I've got my interval. This is also an indication you need to work in degrees. Make sure your calculator is in degrees. Okay, I'm gonna go and try and get theta alone. Yes, some of my students that wrote this paper the other day forgot that when you square root, you have to say plus minus. So if you don't do that, you will lose a few answers, and obviously with that a few marks. So remember, if you're trying to get rid of a square, you square root, and then when you do square root, you have to say plus minus. So at this stage, I would love to split this up now into a tan theta equals 2 and a tan theta equals -2, because both of them will produce a reference angle. So how do I do this? Calculator, you just go, make sure that you are in degrees. There must be a little d there at the top. not an R. Well, I think mine is an R. So that's how you change it to degrees. I'm going to go arctan, or sometimes I just say shift tan because that's the button I press, of 2. That's called my reference angle, 63.43. So I'm going to say theta equals, remember you brought the tan over, that's why I did arctan. 4349, I'll round off later. How does tan work? Tan is just reference angle plus K 180. Remember, you control the K. You can just sub in integers. And then the other option, I'm just going to do exactly the same on my calculator with a -2. Then I get theta equals -63.4349. Just remember, when you do this with tan, you have to put plus K 180. This is just something that you can memorize. If you understand where this comes from the CAST diagram, great. Or you can just memorize tan is always reference angle plus K 180. And what can you sub into K? Any integer. So in other words, 1, -1, 0, 1, 2, 3, 4, whatever, just not a fraction. Okay. Now remember our original interval said anything between 0 and 180. So this one works out nicely. I'm going to sub a 0 into K. So my first answer is actually 63.4. Now I just need to check on my paper. I think they say in the beginning of the paper, we need to round off. I'm actually going to share this with you. When we answer our questions and the angles are in degrees, 1 decimal. Hey, for everything else, 3 significant figures. Okay, so I'm just going to do this. This is fine. This one is not in my interval, but I can make it in my interval. It's negative, so it's not in this interval. But what if I take -63 plus 180? So if I plus 180, that just means I am using an integer of 1 in there. And that produces 116,7. You'll just see I rounded off. I got 116,56. Oh, I'm busy losing it. This must be comma 6. If you round off nicely, don't lose marks for rounding off incorrectly. Come on, we're in AS level already. So these are the 2 that I was looking for in the interval. Okay, so far so good. Let's just go down again. Too far. I also want to show you on the memo where you get marks for. So let's just quickly have a look. 7. For number 7B, you'll get marks for remembering to say plus minus and getting your tan alone. And also then for the 2 angles that I just found. And also obviously rounding off correctly. You saw how quickly a mistake happens. Happy, let's move on. Question 8. I always feel like when we get to question 8, the end is near. So with arithmetic, geometric sequences, series, we have to use the memo, but we also need to use logic. So they say, not the memo, the formula sheet. A geometric progression has first term A, common ratio R, sum to infinity S. Okay, that doesn't really help because that's the normal variables that we always work with. But I'm just going to write this down. So S infinity is S, A is A, and R is R. Fine. Second geometric series, this is geometric progression. First term, still A, common ratio, capital R, sum to infinity, 2S. Okay, I feel like the second progression is a bit more interesting. We're supposed to show that. Remember, if they say show that, you're not actually supposed to know that yet. You're supposed to hope to get to it. You're not allowed to use it. We're hoping that we will get to it. Okay, so I'm just putting this almost like my wish list of getting to that. Also, just notice how I've copied everything down because going from English into maths is sometimes difficult. So everything is on here. On your formula sheet, you will see they do give you sum to infinity on page 1. They give you sum to infinity. I do know it off by heart. I was just double checking. So this is sum to infinity, the formula. So let's write it down for this left-hand side. the sum to infinity is s, and then we have this, and this one sum to infinity is 2s, and it has like a little bit of a funky r. Now remember, we are trying to get to this, so it does look like somehow they eliminated the s's, because I don't see an s anyway. So we can do simultaneous equations. I don't know if you guys remember that. This, we can sub s, or what s is equal to, into s, into my second equation. Just remember, bracket usage is quite important. Okay, so then we've got the substitution. I'm probably sure we're getting method marks already. This can be 2a, 1 minus r, a, 1 minus r. Now listen, we are not solving a here. So a will just be a constant. So I'm going to do something that's a bit unconventional. I'm going to divide both sides by a, because we're not solving a. We're trying to, and a will just be the same on both sides. And remember, we're trying to get to something that looks like this. So the a's are actually not important here. And then I'm suggesting maybe cross multiplying 2, 1 minus r, 1 minus r, and then it's just a little bit of algebra. I'm pretty sure at this stage, guys, honestly, just write what they said. I think we've done enough. Hey, like, oh yeah, I can, yeah, it works out. So we don't waste time, because I feel like we've hit all the method marks already. So we've proven that that is true. Let us move on. Then next question. Okay, I'm sure this is based on each other, hey, because it's A and B, so I feel like they might still be based on each other. So it is now given that the third term of the first progression, yeah, they are talking about the previous one. The first term, let me just read this. It is now given that the third term, T3, of the first progression is equal to the second term of the second progression. Yo, okay, don't lose the plot here. Express S in terms of A. Okay, let me just quickly see what I've written down here. So term 3 of the first progression. Okay, so that's going to look like this. T3, I'm going to use this formula now. On the formula sheet, you get this. And I'm going to sub in, A was A and R was R. But now I have my number of terms is 3. Okay, so I'm just going to write this down for this side. Then they say term 2 of my second progression. That means I'm still using A, but now capital R. And then I've got term 2. Okay, that's all good. And these two guys are equal to each other. That's what they say. That's what they said. So I've got this. And I also have this, I'm just seeing in the corner of my eye. Oh, I should actually make this bigger. Sorry, I don't know if you guys could see that. Term 3 and term 2 from the previous question. And I'm also seeing this in the corner of my eye that I can still use here. And I'm reminding you, A is still just a constant. Hey, you can just divide it away. We're not solving for A. So I'm thinking of substituting this in here. R is 2R, because it is quite difficult to solve two variables with one equation. We'd rather want only one variable. And then when you FOIL this, let me just help you with a shortcut. You go square the first, square the last, and then you go that times 2. So I'm just going to say that is going to be minus 4R. Just making sure, because I do make sign errors sometimes. I feel like that's fine. 4R squared minus 5R plus 1. Fantastic, trinomial. Yes, and I'm running out of space here. Let me just show you how to do a trinomial on your calculator if you want to save some brain capacity for more difficult questions. You go mode 5, equation 3, and you type in your coefficients. I've got 4, negative 5, 1. So just check how you do that. 4 equals, negative 5 equals, 1 equals. And then the answers that they give you here will be the actual X answers, but I do want you to know how to make the brackets. So if the calculator gives you a 1, you'll put a -1 here. And if the calculator gives you 1/4, you actually have to move that 4 back so that when you solve it, the two answers here are r equals 1 and r equals 1/4. And remember, if r is equal to 1, your progression is not going anywhere. So I would prefer you to have then the r equaling 1/4. Let's see if we are accurate. I feel like I went a little bit rogue there. Yes, fantastic. But perhaps let's just see what the question was. Express S in terms of A. Okay, so there's one more thing that I feel like we need to do. Express S in terms of A. So we had this one, 2S equals A1 minus R. I don't know if you remember that from earlier. Then we can substitute this new R that we just found in here. 1 minus 1/4. And then I'm just going to divide the whole thing by 2. So it gives me S equals, it's a lot of algebra here, 1 minus 1/4. Just see 1 minus 1/4. That's going to be in my denominator. And then I'm just going to times that by 2. So I get an answer of, let me just show you, I should get 2a/3. Because I don't know if I should squeeze all of this in, but this is going to be 3/4 times by 1/2. You will get to, if big R was 1/4, you will get to 2a plus over 3. I don't feel like that was a difficult step there. Let us move on. Next question. Are we into 9 already? Yes, we are. We're going into circles. All right. If we go into circles, just remember there are some like geometrical rules that you have to remember. Like tangents and diameters and things, but we will get to it as they ask it. They say the diagram shows a circle with center A passing through the point B. So circle A passes through this point B. A second circle has center B and passes through A. They do mention that this is a tangent. We've got coordinates. Fantastic. We've got the center coordinate there. Center coordinate. Can I just highlight nicely? And then the center coordinate there. Also, we need to have a look at the tangent, the equation of the tangent, CBD. Remember some things like with a tangent, you know that the radius, if I had a radius there, it will always be perpendicular to my tangent. That was what I was speaking about earlier, where you need to know some of your Euclidean geometry to be able to do circles. Tangent, perpendicular, radius. And we have coordinates. Guys, this is actually perfect. Let's just write down A and B. Because if you have enough coordinates, you can get gradient. And if you have gradient, you can get the equation of that tangent. Okay, so let's start with the gradient of AB. Now the gradient of AB, please use this formula, change in Y over change in X. Y2 minus Y1, doesn't matter which one you choose. I chose this one minus this one, but then be consistent. For the X, choose this one minus this one. So that is my gradient. And then remember, if that was your gradient for your radius, have a look. That's the gradient of AB. That's your radius. If you want your tangent, you must remember that if it's perpendicular to each other, there's a rule that you can use. The one gradient times the other gradient must equal -1. But for practical purposes, all you need to do is flip it. So I'm just going to say the gradient of my tangent. You flip it and you change your sign. And if you have all this information, you can start by doing a straight line, because remember, tangent is y equals mx plus c. I've got my gradient. You just have to check on the sketch which coordinate actually lies on your tangent, and that's coordinate of b. So that's this 3 and 2. I can use this into my y and into my x, and then I can find c. That's pretty easy. A little bit of algebra. I'm not going to do that. That's too easy. So the final answer I'm looking for the equation of the tangent is this. I know, I don't like the way that they write it in that form, but I'm pretty sure I would have gotten to the same answer if I kept it in standard form. In standard form, it's like y equals mx plus c. So that would have been y equals 2x minus 6 minus 4 is what I would have gotten. So c is -4. Okay, that was nice. Let's see what else they want. Now we have the equation of the tangent, if you might need it later. They say find the equation of circle with center B. So we want this circle's equation. Unfortunately, on your formula sheet, the equation of a circle is not printed there. So this is something you have to memorize. X minus a squared plus y minus b squared equals r squared, with a and b being the center of your circle. So they're asking specifically for the equation with center B. So I'm going to use my B coordinate right into 3 and 2. I'm going to use it right into the A and the B. So my B coordinate had a 3 for my X, and it had a 2 for my Y. But now you also need to find the radius. So the easiest way to find radius, obviously you could use distance of diameter, divide by 2, but I feel like the sketch is going to help us here. If you want the distance of the radius, why don't we just substitute the coordinates of A into X and Y? Or you could have even done a separate question where you just do distance formula for AB. The circle formula is basically the distance formula, just a little bit different. I'm going to sub in the coordinates of A into my X, into my Y, and I'm going to find R. Now I remember that R was 20. So it's just, yeah, again, I'm going to skip the easy stuff. You just find all that and substitute it back, 20. So I need that maybe for the next question. So I'm just going to write that. It is r squared, right? So if you get distance to be square root 20, your equation needs proper 20. So you need to square your radius to get it in this form. Nice. Equation on the circle center B. Find by calculation the x coordinate of C and D. So if you want C and D, let me just focus your attention there. I hope that your problem solving skills are telling you that C and D are not just coordinates, they are points of intersection. That is where the circle intersects the tangent. So these questions that we've been doing are actually very useful at this stage. So if you have the circle's equation, this is now the proper circle's equation. And you have the tangent, I can even see this, the tangent still. If you have the tangent and you have the circle, you basically want to know where they satisfy each other, basically. So where they intersect. But you're not going to get y alone here. Don't try and do it the traditional method of setting them equal to each other. Rather, substitute this y. Let me use some color. Let's substitute this y right in here. And that will actually give you point of intersection. Again, this is going to be a lot of nitty-gritty algebra, which I don't really like doing. So I'm going to sub it in here. 2x minus 4 minus 2 squared equals 20. So please excuse me if I don't want to do all of this, but you square, you FOIL, do all that. And get x. And then when you're done, sub it back and get y. This is what I want. I want you to get to 2x values. Oh, fantastic. They only asked for the x coordinates. If they ask for full coordinates, obviously you have to sub it back. But if they're just asking for x coordinates, that's all they want. So you sub it into, I don't know if you saw in the memo, the method there, sub like square times everything out and get 2x values. Nice. Nice. We're into the teens now. I think there's only like 2 more questions. Let's do this. Question 10. Now this is quite a tricky diagram where there are quite a few things to remember. Circle theory. Again, if you know that a tangent and a radius is perpendicular, then we have a 90 there. If you know that C is the center, because I do mention something about sector CAB having a center of C, this is a radius. This is a radius. They're all equal in length. And we also have a circle with center O. There's my circle with center O. So these are also the same length, R, all the way. They say COD is also a straight line. And we've got this angle to be theta. The question, first question, find CD in terms of R and sine theta. So they want CD. So this long one here, they want CD in terms of R and sine theta. So the critical thing that you had to notice here was that F is 90. So if F is 90, then suddenly we can play with our trig ratios. So the trig ratio I was hoping for was if you use this angle and you, for instance, want CO, you can use the ratio from here, opposite over hypotenuse. Remember, if you want to just draw your 90 in there, because opposite of your 90 is always hypotenuse. So trig is all about ratios. If you're working with this angle, opposite over hypotenuse is sine. So I've already identified that sine theta equals FO, so R over CO. Just make sure that you've got that already written down the way that I've got that. So sine theta, opposite over hypotenuse. You've seen before that if you want to get CO alone, you times it there and you divide the sign there. So you can just swap the two. So it's just going to become this. Using simple trig ratios. Okay, but then remember they want CD. So the half the battle is already won. You've got CO. Just remember, OD is just another R. Radii. So I'm just going to plus R to my answer. Check, they've got CD is equal to R plus, let me just get my highlighter. All of this I need to be highlighted. This is what I wanted for this question. Okay. Maybe we'll use it for the next question. But for now, let's just write down CD is equal to R plus R over sine theta. 3 marks just for doing trig. Fantastic. Now B, they ask for, find the perimeter of sector CAB. They give you R in this case, and they give you theta. Do you notice that theta has a pi, which means if you do work on your calculator, you need to be in radians. Find the perimeter of sector CAB, okay, in terms of pi. Look at where is CAB. So we definitely want this distance and this distance. But remember, all of these guys are the same. So CD that you worked out in the previous one, just take him, which is the same as CA and CB, and times him by 2, because then you already have half your battle won. And they say perimeter CAB. So take CA and CB, and then you've got that already. Let me just maybe do that. Lots of talking and no doing. So we want basically this, but 2 of them. So I'm going to say for the perimeter of CAB, it's going to be R, which they just gave me. What was R? R is 4. So I want 2 of these guys. And I have my sine. I even have my angle. It was 6 pi. Just to remind you, this needs to be in radians. If you don't know how to put your calculator in radians, let me show you. You go shift setup. 4. You'll see there's a little R then at the top to say that you are in radians. So let's type in this whole thing. Type. I just want to show you this part. This first part is basically 12. Okay. If you want, trying to do shortcuts here now. Lazy. Don't want to type it into my calculator. Let me just do it. 4 over sine. Let me just show you what I'm doing. I'm not going arc sine though. I'm just going normal sine. Okay, and I am in radians. Just make sure the amount of brackets that you have. Yeah, 24. I was trying to use the memo there, but I think it's better to just use your own calculator. Well done for the first part of this perimeter, but we also need to plus then whatever that arc was at the bottom. Because it was great to get the perimeter. So we have CA and CB, but we need this arc AB. And there's a formula. There's a formula on your formula sheet. Arc length of a circle. They say equals R theta. So I'm just going to say we need to plus here R theta. The R being your radius and the theta being the angle that subtends the arc in radians. So I've got my radius. My radius was, I believe, 12. Hey? The radius is from here to here. That was 12 units. And my theta will be two of these theta radians. So they gave me that. It was a 6 pi. So have a look at what I use here. I use for my R, I use 12. And for my theta, I use 2 6 pi's. And now I can use the memo a little bit if I'm feeling lazy. Yeah, 24 plus 4 pi. That is called exact value. Okay, we didn't round off. We are just keeping it in terms of pi. Perfect. And then they ask for the area of the shaded region. So let's go on to C. B is done. Then they want the area of the shaded region. So for that to happen, we need a plan. So the plan I was thinking of is maybe working out this triangle. You can even just do half base times perpendicular height. And then I'm going to minus this little sector. And then I'm just going to take that area and double it. Okay, so let's just start with my plan. My plan will be to work out a triangle, half base times perpendicular height, and then minus some kind of sector area. But my sector area that I'm going to use, this is the formula on your formula sheet. Half r squared theta, again theta being in radians. Just having a plan can already sometimes give you a method mark. So if we want half base times perpendicular height for the triangle, we have R. So we just need to find FC. Again, I want to remind you that we can use trig ratios. So this will be, if we want CF, and we're working from this angle, it will be opposite over adjacent. So I'm going to say tan theta equals opposite, which was R, over adjacent, which was FC. And then let's see if we can sub in some values here. Remember, we do have theta, the 6 pi, and we do have R. R was 4 over FC. Remember, I've shown you many times now that these can just switch. So quickly work out for me, what does FC equal? I would love to know what FC equals. Let's type it into our calculators. Don't remember, you are in radians still. So we're going to say 4 over tan of 1 over 6 pi. Because I get 4 root 3. Fantastic. And then let's just follow this process. If we want the triangle, we go half base times perpendicular height. I don't know if you remember, but from the sketch, that is my perpendicular height. Minus then, and now we need to think carefully about this sketch again, because we haven't spoken about how we're going to get the sector. But the sector is not bad, guys. If you look at this, if we need to get this little sector here, we need this angle. So if you want this angle at O, this little one, you can just do interior angles of a triangle, adds up to 180 degrees. But in terms of radians, it'll add up to pi. So I am going to use that. I'm going to say for this theta, maybe like a little side calculation. For this theta to work, I'm going to go pi minus 90, so half a pi, minus the other angle that they gave me, which was a 6th pi. Calculator work, or for those of you that are very clever, you can do this in your head. Okay, that's a 3rd pi. So I'm going to go a half my radius for squared, and then I'm going to say a 3rd pi. I think that plan works out nicely, but I'm not going to be lazy. Let's type in everything in our calculators. As soon as it gives you a decimal, then it's game over, because they did say in terms of pi's and root 3s. So I just typed this one separately. Okay, and then times 4 squared times 1 over 3 pi. 8 over 3. I wonder if this is good enough. Let's quickly see if that was good enough. 10C. Maybe they want us to, what else do they want here? 8 over 3. I think this is equivalent to each other. If we type in both of them, 16 root 3 minus 16 pi over 3. So I'm just quickly checking the memo gets 10,95. Let's see what I got. I'm missing a 2 somewhere. Okay, well, this is where you just take a deep breath and you see somewhere you must have missed something. Perimeter. This is where I miss my live classes, because then it's normally a very clever student corrects me. It must have happened, let's see, half base times perpendicular height, half r squared theta. This is FC, half base times perpendicular height. It could always happen perhaps where you typed it in. So let's just follow that again. 1.5 times 4 squared. Oh, guys, honestly, I almost got a heart attack now. You just have to times this by 2, because I've only worked out half of this. Can we just remember our original plan? We said, yes, we're going to do all of this, but that's only for this area. Double it. Okay, thank goodness I didn't make a major error. And we've got 11 now. Let's move on to 11. We are getting closer and closer to the end, but this is also where we normally get tired and we start making silly mistakes. So for 11, let's just quickly write down what they've got there. We've got f of x is equal to x squared plus 3, and we've got g of x 2x plus 1. Okay, so let's just do the compound function. For 11a, they ask you to do f of g of x. All that means is you need to sub g into the x of f of x. So this g needs to go into the x of f of x. And brackets are your friends. If you have no other friends, brackets are your friends. So what we need to do is inside that x, we sub g of x. And that's actually fine, hey? It's just 1 mark. You could have obviously simplified this a little bit, but I feel like if they're not going to give me and reward me with marks, I'm not going to do more than that. Let's see if that's enough. It is. Yes, 1 mark. 1 mark, 1 brain cell. Next question, they want you to take what you just created, the compound, and they want you to do the inverse and then state the domain. What will be the easiest at the moment is when you look at what you've created, you have created a parabola. So maybe just even a small little sketch of your parabola. This is your turning point. That might help you because this is now for your original. So before we inverse it and create chaos, maybe we should just write that down. Did they give me anything else that I need to worry about? No, I'm just going to write that down. So that means for your original, what is your domain and what is your range? I would just want to focus on the range especially. The range here says y must be bigger than 3. So if you look at your original parabola, this is your y, because for the next question, they ask you to find the inverse and then the domain of the inverse. So if this is your range of your original, it will automatically become the domain of the inverse. So that's already a mark, by the way. Before we get distracted with finding the inverse, let's just get the range becomes domain. Okay, and then the process starts. When we try and do the inverse, the first step is transposing x and y. That means take your x, take your y, and swap them. Fancy word, transpose, but you just swap them. And then the second step would be get y alone. So carefully, step by step, bring things over that are loose. Squares can be square rooted. So that's what we've got so far, square rooted. And then what we need here in our final one, we've got plus minus root x minus 3. The square root is gone now, so we've got 2y. This one can come over. And in the final step, I can take this, x minus 3, you can choose the positive option, minus 1 over 2. And we've already got our domain. Just want to quickly see if that is what they wanted. The inverse, so they just wanted inverse in any form, and then also the domain. Fantastic. I hope I haven't lost you guys there. We are choosing the positive option because you can see the domains are all positive. Why do I feel like I'm missing something? It felt just very easy. Okay, so inverse, get x and y alone. Oh, swap x and y, get y alone. Then let's quickly do C. I feel like this paper needs to wrap itself up now. The next question, they want you to take f of g of x. Don't forget that you've just got f of g of x in the first question. And then they want you to set it equal to g of f of x. Okay. I want us to do as little as possible. Don't do f of g of x again. You still have it there. We just literally just did it. So from 11a, just copy down f of g of x. This was f of g of x. Now be careful, after f of g of x, they also say minus 3. So don't forget them, there's minus 3. And then they want you to create g of f of x, which means into g, which was 2x plus 1, you sub your f. So this is like the other way around. But still, brackets are your friends, right? Okay. So what have we got so far? We've got this 2x plus 1 squared, the plus 3 minus 3 gone. And then we've got this guy, 2x squared plus 3 plus 6. You see what I meant about getting tired at this stage of a paper? Multiply plus 6. What was the question? Just solve this. Let's see. Solve the equation. Okay, I think the rest was easy. I don't have to do that with you. Just foil, bring things over. I don't think I need to do that with you because I don't want this video to be too long. We've got one more question with 3 parts. Let's push through, let's push through. Okay, that was 11C, sorted. Now, let's go on to number 12. Okay, this is actually my favorite type of question because it's purely calculus. You can see there's a diagram with a curve and a straight line. Let's just write down what they've got. This is my curve. Y is equal to 4x a half minus 2x, but it's only sketched where x is bigger than 0. You can see that on the sketch. Then we've got a straight line. Y is equal to 3 minus x. They say the curve crosses the x-axis at 4 and crosses the straight line at B and C. So that's basically point of intersection. Okay, that's what they want. First question, did you see how I noticed that B and C again are points of intersection? This is actually a theme now in this paper. Keep asking me for point of intersection. So in this case, I can just set them equal to each other. Okay, so let's have a look. They are in standard form where y is alone. It's not like it's a circle. With a circle, we had to sub the one into the other. But for this one, look at point of intersection. Lovely. Just like that. If you notice, this is a trinomial. Maybe it's difficult to notice that. I'm just going to bring everything to one side. And I am going to write them in descending powers of x. I'm changing my mind. I'm going to bring them this side. So bring it over. This is my highest power. Then this one. Then this one. Don't make sign errors. I know we get tired at this stage of a paper, but naught on the one side, bring this over, highest power, second highest power, and then I want you to identify that this is a trinomial. It's double or nothing, double and nothing. You double the thing on the one side and there's nothing on the other side, then you know it's a trinomial. So I'm going to again do my special mode 5-3. Doesn't matter that you're in radians. Coefficient 1, -4, 3. 1, -4, 3. Okay, brilliant. I've got x is 3. So my first bracket, the answer is 3. So the bracket must be -3. Just have a look. It's not normal x's, it's x halved, because that times that must produce that again. So you have to be clever. Calculator helps you, but it's not going to do everything for you. The other answer is 1, so I'm going to put here -1 equals 0. So then I've got x to the power of a half equals 3. X to the power of a half equals 1. Don't stop there. Square both sides. So x is 9. X is 1. Sorry, I'm rushing a little bit now, but I feel like I really just want to finish this paper. The x coordinates of B and C. Fantastic. It was 1 and 9. I don't think they need us to specify which one's which. No, just say 1 and 9. And we are happy. Next question. Show that B is a stationary point on the curve. Stationary point means derivative equal to 0. No gradient at a stationary point because you are perfectly horizontal. We need to show that B is a stationary point. We can do that. Let's take our curve and let's derive it. By the way, never drink and derive. Very important. Okay, so that is my curve. Let's quickly derive it. Remember, how do we derive? Times to the front, subtract 1. Times to the front, subtract 1. Don't integrate here. Oh, that's not big enough. Okay, don't integrate here. We are deriving to find this. And we need to set it equal to 0 because that's a stationary point. I don't know if you want to drop this down. Always feels like it's easier to solve it like that. And then whatever method you want. 2 equals 2 over x halved over 1. Shall we cross multiply? Starting to write more and more neat. Okay. 2x half equals 2x half equals 1. So x, if you square both sides, is 1. And remember what we said earlier, the b there at the top, that was my b coordinate. So we've just confirmed that just make a little conclusion and say, therefore, B is stationary. Okay? Stationary, not the one that you write with, that's an E. And we've proven it. How many marks did we get for that? 2 marks. We did show that B is a stationary point. We didn't use it. We were just showing that it is stationary. Then last one for 6 marks. I know some of my students left this question out when they wrote this. Just due to time constraint and stress, the area of the shaded region. That's a perfect way to end today, is the area of a shaded region. So we integrate the top minus, and then we integrate the bottom. So let's just quickly do that. Let's say the curve and then the straight line, because it does look like that is the 2 that we're dealing with. So we integrate the curve. We will do that. And maybe we should just do them separately, and then we'll integrate the straight line as well. What was the straight line? 3 minus x. Okay, just to remind you how to integrate, you can move this a little bit. When we integrate this, you add 1 to the top. So you add 1 to your exponent and then divide. And then you add 1 to your exponent and then divide. We will chat about the boundaries just now. I just want to quickly integrate both of them. Same with this one, and then you can put your brackets, which shows that you have integrated. You don't have to put a plus C because we are going to talk about boundaries just now. So for the next one, you will say 3x minus x squared over 2. So now that we've integrated correctly, let's apply our boundaries. The problem is we'll have to just quickly